Okay, in this lecture video, now we're going to look at bases and what their definitions are. So there's lots of definitions for bases, just like there were with acids. The first is that it results in the production of the hydroxide ion when dissolved in water. And notice that it says production. So acids, on the other hand, release an H+, but a base results in the production. So that means the base may or may not have hydroxide in its chemical formula. The second definition here is that bases act as proton acceptors, so they can accept a proton from another substance. Of course, if the base is accepting the proton, the other substance must be giving the proton away, which would make that other substance an acid. And again, we'll look at that a little bit more in the prep activity and the in-class activity. But let's focus in on definition 1 here. So our first example would be sodium hydroxide. So when you have solid sodium hydroxide and you dissolve it in water, we know that sodium hydroxide is an ionic compound, so it clearly will break apart into the sodium cation and the polyatomic hydroxide anion. And so in that it released the hydroxide ion, or it resulted in its production, that defines sodium hydroxide as a base. So in this case, hydroxide was actually in the chemical formula of the starting molecule of the base. Look at another example. And so in this example, we're looking at ammonia, which is also a base. So if you dissolve ammonia in water, you result in the production of ammonium, NH4+, which is one of our common polyatomic cations, and you still result in the production of hydroxide. So let's take a look at where that hydroxide came from. It actually came from the water molecule. So this is getting a little bit into definition number 2. So if I were to draw my water molecule like this, you could see perhaps that the ammonia, when you look at this water molecule, one of these hydrogens got transferred to the ammonia molecule to take it from being NH3 to NH4, which gave it a positive charge. So it took one of the protons off the water molecule to make the polyatomic cation, and then what we had left was the hydroxide anion. So ammonia resulted in the production of hydroxide via a reaction with the water molecules. So in essence, this is like definition number 2 of bases, where the ammonia accepted a proton from the acid. Now that's going to make water function as an acid here, and we'll get to that later. But just like with strong acids and strong bases, you can also classify, strong acids and weak acids, you can also classify bases as being strong or weak. And typically the way we think about it is if hydroxide is contained in the chemical formula of the base, like sodium hydroxide, then it would be considered strong. And all of the sodium hydroxide molecules break apart to release all of the hydroxides. That's what makes it strong. So strong base, strong electrolyte. Whereas in the case of ammonia, without hydroxide in the chemical formula, ammonia, on the other hand, is a weak base. So not all the molecules result in the production of hydroxide. So you have fewer hydroxide ions, making ammonia a weak base or a weak electrolyte.